Everyone, this is our final project, and I'm Kenny.
I'm Cynthia.
And I am Thomas.
And I want to start out with an explanation of the scope of our work before getting into it. And starting out when we were thinking about the game concept, we want to think of something relating to trivia. For example, we were thinking about making a matching card game, but we ended up on Hangman, and we modified this game by making it a math game with a melting snowman, where users will start out with a fully built snowman, then answer math problems, and each time they get a math problem wrong, the snowman will slowly melt. And if the user keeps getting problems wrong, they'll eventually melt the entire snowman and will fail the game with a given you lose screen. If they successfully answer 10 math problems, the snowman will not melt, and they'll succeed in keeping the snowman from melting, and the user will be given a you win screen with a wiggle animation. So the user can then type again to keep playing, or close the game and run the program again if they want. And now all users will start with an animated title screen that moves up and down with buttons that allows them to pick the difficulty of the math problems ranging from easy, normal, hard, and insanity. So we set up the game name as Melting Snowman to represent the melting snowman. In terms of splitting up the workload, I set up the GitHub and created the title screen animation. Cynthia created the graphics, UI interface, and end screen animations. Then Thomas created the problems for users to solve and created the snow animation. And while setting up meetings, we decided on an asynchronous meeting model and collaborated through GitHub, then met over the weekend to thoroughly consolidate and combine our code, making sure there were no conflicts in our code. And working together on our code was definitely tough at first, but we were able to get over that hurdle through taking turns when uploading our files and splitting up the work into individual contained classes rather than one class. And we ended up using these best practices in software development collaboration to ensure we were on the same page and also maintained communication throughout the project through Discord. And so moving on to the details of the code itself, before we get into the game, let's look at the main class here, which will invoke the game. And this is setting up the panel for the game to be placed in. And starting on the first line, this is just setting up the JFrame, which allows us to create the UI. And frame.setSize allows us to set the size to 500 by 500 pixels, the size of the panel. And resizable, so this is focused on absolute positioning and allows us to place the images where we want relative to the other pixels. And then set title allows us to set the title of the panel, which is the name of our game. And the next default close operation, on close it'll exit, and home screen will add home screen to the panel starting out, and set visible will set the panel as visible. And moving on to Cynthia.
Okay. So for the game panel, we imported a lot of packages. So we did image IO, swing, AWT, just so we could deal with all the graphics. So for the class, the public class is game panel and it extends to JPanel. And then we have our private JFrame, which is just linking the game panels to the frame. Then we also have a private final int width, and then that's just setting the width of the frame. Right after is also setting the height at 500 for both. For the color background, we decided on blue. And then we're getting into our constructor game panel. And then that is just setting the size of the game panel using the data fields of the width and height. And then the same thing with background color and just setting it for the blue. And then we're going into our get width. And this method is just a getter method for the width declared, and then it just returns the width. Following that is the get height method, which is then returning the height. And now we're going into our public color, and it's just returning sorry, not public color, the get background color, and that's just returning the background color. And then following that is then the public void set frame, and it's another getter method that's declared with parameter frame. And then it's just assigning the frame to the data field. And we're getting the public JFrame get frame, and then it's just a new JFrame getter method. And then returning the get frame data field. And then we're getting the buffered import image for importing and declaring with parameters. And then we're doing a try catch. And so it's just going through performing the action, returning the buffered image using the file path parameter, and then it's catching if there's any exceptions that is unable to perform because of those exceptions. So yeah.
Awesome. And thank you, Cynthia. And we'll get on to the first panel the users will see when they run the game, which is the home screen. And so at the start here, we're just extending game panel with home screen, and we're creating the buttons. And so this will say, as we mentioned earlier, easy, medium, hard, and insanity. And then here we're setting up JLabel, and looking down here, title screen Y and title screen timer. So this integer variable represents like the vertical position of the title image, which allows us to create the animation. And so it'll move up and down in the animation frame depending on the integer value. And title screen timer will just allow us to slow down or speed up the animation. And so right here, this is the constructor for home screen. And quickly going through this, we're linking the frames to the home screen, creating a new button panel, getting the background color from game panel, setting up the button panel size containing the buttons, and then adding the absolute location of the buttons, then calling back to button panel location for the location, and calling back to the button panel size to set the size. And so with JButton together with Action Listener, this is going to fire an action event when the users click on a button, allowing them to go through into their chosen difficulty. And going down here into the image, we're defining the image by importing title2, which is the title image, using a relative path. And this sets the image as an icon. And here in get scaled instance, we're scaling the image to the size we want, 500 and 400, which allows space for the bottom text panel. And then we're adding a button panel to the image as well. And finally, adding the image to the home screen. And so here, more details on the animation. Moving up, this is a Boolean variable that determines the direction of the animation. When moving up is true, the title image moves up, and when it's false, the title image moves down. And so here we can see, let's see, next to new timer 70, this is the timing of the event. And then using if else, it's going to move the title screen up and down. Yeah, so as you can see, there are different integer values there. And moving on to the bottom here, image set location. The location will be based on the X and Y value. And then finally the timer as well. And so moving on to public void action performed. And so if a button is clicked, it'll go through the play screen depending on the button clicked. So depending on the difficulty they choose. And so repaint here, a really important method that we use throughout the program, and it's responsible for handling the updates to the paint cycle of the applet. So whenever we want to component to repaint itself, aka like move on next screen, we call the repaint method. So, and moving on to Cynthia again.
Thanks. Thank you, Kenny. So now it's going on into the play screen class. And so for the play screen class is pretty much an extension of the game panel. And so this is representing the screen of the game where just showing all of the difficulty levels. And so the first things first is a bunch of variables that are just being initialized, trying to think of the word, initialized. And so each one going through the wrong answers, initializing 0. For the problem index is 0. Problems itself, we decided on doing 10 problems. And then for the images, we're doing 5 to show that the snowman is slowly melting with 5 images. And then initializing the answer box and the problem field. And then also the guess button as well. And then we're going into the snowflakes, which is 15 snowflakes. That's how many snowflakes we have on the screen. And now we're getting into the public play screen method or a constructor. And it just accepts 2 parameters, a string representing the game's difficulty level and a JFrame object. And then following after that is the set layout, set frame, set size, set background, and that's all just for assigning the J-frame and the color of the panel, generating the set of problems on the selected difficulty level. Okay, and then on to the next. This is final int element y location. final int element height location and space of elements. This is just setting up various constants relating to the position and sizing of the elements on the panel. And then we're moving on to the answer box, and it's just setting the location and setting size for answer box. Okay, and final int problem field center is 125. It's just everything in regards to the problems itself. So it just sets up the problem field by positioning it, setting an editable property to false so nobody can change it as they're playing it or the gamer, enabling word, setting up the font, setting up the text, and setting the background color to light gray for the box. Yeah, kind of thing. Going over if and else. So this is just for J option dot show message dialog, and it's just prompting the user to enter their number or their answer. And then following that, the else if is again, if the user decides to play again, then all they do is type again. And it's ignoring the case, so it's not case sensitive, so they can type it any way they want. As long as they type it correctly, it will start again. And then following with get frame add, get frame reevaluate, and get frame repaint to just cover it over so then the proper frame can start over again. We're going through, and then for the if problem index equals problem length -1, that is just going over if the user answers all of the 10 problems correctly, then they get the win message, and then starting over. Yeah, so problem index increment, and problem field set bounds. This is all just for the problem field itself. Else if wrong answers are image length -1, get frame remove, and this is all just in regards to the title or the lose screen. So if the user ends up getting all of the problems wrong and they use all of their attempts up, then they get the lose screen. Okay, else, and then this else method or this else part is for the snowflakes, and it's just animating the snowflakes and helping that. Next. This is a JLabel. This is for importing the snowman images. And so it's just setting, importing it image icon, and then setting the bounds for it so it's showing up properly on the GUI. And then we have the animation panel set background color. And then this is all just for the visuals where the snowman is located. That layout. And then these are all just adding everything onto the GUI. So the answer box, the problem field, the guest button, and the animation panel. So everything that's being called to that is then being populated. And then this is for the snowflakes. So this is a snowflakes animation part, a little bit of it, just helping to render it over into the GUI. And yeah. And then onto the end screen. So for the end screen, this is just the final panel. And so this is demonstrating or the visuals and all of the code in regards to whether the user wins or lose. And yeah, given the different results, we'll show different visuals. So starting off, we're importing all our packages, and then we're extending to JPanel or game panel. And then let's break it down. Doing JPanel, UI panel, new panel. JLabel, outcome screen, private timer, wiggle timer, and private boolean is wiggling equals false. These declare and initialize instant variables. And then JLabel is displaying the outcome of the image, and timer is for the wiggle animation of the win. And there's a boolean variable to track the wiggle animation. And then we're going over to the private void. Oh, the private void. Can you scroll up a little bit, Thomas? And private void start wiggling animation. Okay, yeah. So that's the wiggle timer. And yeah, it's just setting the timer for the wiggle so the wiggles move a certain way. The Boolean shift is true, sets the out screen to shift to the left. Public void action perform, and then there's the action event. Overridden method action performed is defined. If shift checks if the shift is true or false, then it shifts the x coordinates, and then else runs if the shift is false, shifts the x coordinates of the outcome 5 units to the right. So the first one shifting to the left, second one shifting it to the right to kind of give that wiggling or shaking effect. And then if outcome is win, checks if the outcome is win or lose, then the wiggle timer starts. And then it can wiggle the win.
All right, so let's get actually into the logistics of the problems themselves. And so this is the parent class from which all the other problem types will derive from. So each problem class will have data fields question, answer, and problem size. So this is just the question. This is the answer. This relates to the problem text field in the play screen. And so these are our getter methods for question and answer. These are our setter methods for question and answer. And what this is the public static object array. And so what this does is that it will generate some sort of random operator. And what it will do is that in the first element of the array, it will generate the string. In the second of the element of the array, it'll generate the answer. So what we can do is that we can sort of like use this array in order to like conveniently get our questions and answers whenever we do operations like addition, subtraction, and multiplication. And if neither of these things are called, then this exception is called. Usually this statement will never be called though. And then it'll return the output. And then this is our setter and getter methods for problem size, which we use for our problem field. And this just returns the question as a string. So if we want to like print something, right? Okay. So next is easy problems. So what this class does is that there are two data fields, num1 and num2. They're essentially the same. And these two commands will randomly generate a number between 0 and 10 inclusive. And using our random operator function from problems, we can set our question with the first element and set our answer as the second element and set the problem size to 80. So moving on to medium problems. So what we have here is that, again, we have our problem type generator that will sort of switch between problems. So it'll generate a number between 0, 1, or 2. So if it's 0, it'll create a, it'll basically make arithmetic problems, but the numbers are bigger, and it will call this random operator again, like we've discussed in the problems class. It'll set the question as the first element, answer the second element, and the size as 110 for problem field. And so this case will make exponent problems. And so what we have here is that we have a base and an exponent, generates a number between 1 and 5, blah, blah, blah. And so what this does is that we'll set our question, right? So it's our base and then the little hat thing for the exponent and our exponent in question. And our answer will just use math.pow. And our problem size is 100 again. This case will create LCM problems. And so it'll generate a number between 10 and 29. Same for the other one. And it will just run through each of the numbers between 10 and 29, or it'll run through 1 to whatever like the smaller number is, just to find common denominators, right? So we have the modular here equaling to 0. And then that's to find the GCF. And then the LCM, least common multiple, is just the greatest common factor times each of the other numbers divided by that factor. And so it'll set the answer, set the question, and set the problem size. So if we move on to hard problems, so what we can do is that we can create this problem type generator again and switch there. So when it's 0, it'll be the sum of the first n terms. So it'll generate some random number between 50 and 99. And it'll basically ask 1 plus 2 plus 3 plus blah, 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 all the way up to like second to biggest number and then the biggest number. There is a formula for this, which happens to be n times n plus 1 all over 2. And the problem size is set. So in this case, we, sorry, I'm like, oh, this creates exponents, but they are harder than the medium exponents. This time the numbers are bigger as well as the powers, and it is the same idea. Other than that, it is the same. This one will generate factorial problems. So it generates just one number. And if that number happens to be 0, 0 factorial is 1, so the answer will be 1. Other than that, it'll set the answer to 1 and iterate all the way up to the number. It'll just keep on multiplying each number, which essentially is what a factorial does. And it'll set that as the answer. And so the question will state the number and this exclamation mark, that just means the factorial. And it'll set the problem size. And move on to my favorite problem, the insanity problems. Again, there are 3 types of questions. This one's the sum of the coefficients of a binomial expansion. Sounds very complicated. And it kind of is. And so essentially, we will randomly generate 2 numbers between -10 and +9. And we will set some random exponent between 3 and 6. And so what we will do is that we will say that the question, it's a long question, sum of the coefficients of blank x plus blank y, the exponent power. And so the idea here is that the answer, there's an idea where when you're doing binomial expansions, so it's like x plus y to the 10th power, you're able to add powers and take that to the 10th power. So it'll be 2 to the 10th, which is 1024. That is the idea that we're implementing here. And we set the problem size. This one changes numbers from hexadecimal form to decimal form. And so it'll randomly generate hexadecimal numbers. So we use this hexadecimal base. Well, hexadecimal is base 16. And we're using 3 digits for this one. 4 digits is a little bit much. And we're setting the answer to 0, just initializing it for now. And what we'll do is that for each slot in the digits array, we will, sorry, we will set a random digit, which digit is used loosely here. And then what we'll do is that we'll say that the answer is each digit multiplied by the hexadecimal base to the something power. So it's the same idea as saying 100 is 10 squared. If you have like 100 base 16, that's going to be 16 squared. base 16 versus base 10. And then the output is going to be empty, or represents the question. And again, we're iterating through the digits. And essentially, we're making a switch case for all the non-normal digits, because normally you don't have a digit 10, 11, 12, 13, 14, 15. So that's why we use A, B, C, D, E, and F. Other than that, digits are just going to be digits. So 0 through 9 are all good. And we will set that question based on the output, set the answer based on the answer that we've obtained above, and set the problem size. Case number 2, modular arithmetic. Actually, my least favorite one out of all of these. But what it does is that it'll take a number, take some very large exponent, and take it to some mod. And so right now we've set the answer to 1. And basically, as we're iterating through the exponent, what we can do is that we can multiply. So the first time we do it, it'll just be 1 times the number, which just gives us the number. But after that, what we can do is that we can say number. So it's a very modular arithmetic thing. What we can do is that we can repeatedly multiply and then take the mod of the number. And as we keep doing that, we will be able to get to the answer eventually. That's what this for loop does. And then we set the question using our little exponent mod. We set our answer according to this answer, and we set our problem size. And now I'd like to explain the snowflake. This was used in the play screen, if you remember. What it does is that there's a few data fields here. There's a private timer, private dimension size, which will give us the width and height of our snowflake, and a random speed that will be generated for each snowflake. And so what this does is that, so what we can do is that we can sort of link up the panel to the snowflake, and essentially we can set the location based on the panel's width and dimensions in general. We can set the size of the snowflake according to this size, and we can set the background of each snowflake as white because snowflakes are white. What we can do is that we can get the image snowflake.png, which is simply just a white square for this one. And if that a file happens to not exist, it will throw a runtime exception. But in this case, if everything goes correctly, we will not need to worry about that. And then here is how we deal with the actual timing of the animation. So we have a delay of 70 milliseconds, and we have this little action listener. And so as we go through, it'll keep receiving the Y value of each snowflake, and it'll test if that Y value is going to be bigger than the height of the panel, which really just means it's like lower than the bottom of the panel. So it'll just reset it back to the top with a little twist that it changes the X coordinates as well. And then it will otherwise set that location. It'll just keep falling down based on speed, which is declared the data field up here. And then it'll start the timer just to let the snowflakes fall. And so if we want a demonstration of our program, let's let it load. There we go. Okay. So if we choose easy, there we go. A little bit slow today. And so as you can see, the snow is falling, and if we wait for it to fall all the way down, it'll rise back to the top. And if we answer all these questions, Let's just speed run this real quick. Okay, that we win. And there are our two buttons. So we can either press again, which will take us back to the home screen. And let's say we lose because we are, as you can see, the snowman starts dying, which is sad, but such is life. And we get the you lose screen. And again, we still have the option to play again or quit. If we quit, it just closes the game. And I believe that is it for our final project. Thank you for listening. Have a wonderful rest of your day.
Thank you.
Thank you.